This type of problem is quite lengthy, so bear with me. There are 3 parts to it. I'm going to cover all 3 parts in 3 different videos. So this is dealing with problems that are talked about on example 6 on page 665 of your textbook. We start off with, suppose A and B are angles in standard position. Remember, that's where the initial ray is on the positive x-axis and then it's terminating in one of the 4 quadrants, or of course it could be a quadrantal angle. But A and B are angles in standard position, and they give you the cosine of angle A is -7/25. They also say what quadrant angle A is in, and they say it in this manner. They say A is greater than pi and less than 3 pi over 2. Well, that puts angle A in quadrant 3. Sine of angle B is -3/5. B is greater than 3 pi over 2, less than 2 pi. That puts angle B in quadrant 4. So it's kind of good to write that down and just kind of know, here's quadrant 3, just to keep that in mind. Here's quadrant 4. Just so you know, A is in 3, B is in 4. Alright, so the first part we're going to do, part A. There's 3 parts, A, B, and C. Part A, find sine of A minus B. Well, this means we're going to wind up using a sine difference formula, so you have to remember what those look like. So as a brief little reminder, here's the sine of A minus B. Sine, cosine, cosine, sine. The signs in between the products are the same for the sine sum and difference, right? When it's plus A and B, it's a plus in between. But sine, cosine, cosine, sine for both patterns. So we're going to follow this second pattern here. Sine of A minus B. So let's write that out. There's going to be a lot to this, but if we have the sine of A minus B, let's find out what we already have. First of all, we've got the sine of A times the cosine of B minus the cosine of A times the sine of B. That's just following that sine, cosine, cosine, sine pattern of the formula. So this literally is the sine of a difference formula. And we know that each one of these, cosine of A is a ratio, right? Cosine of B is a ratio. Cosine of A is a ratio. Cosine of B is a ratio. And we've been given 2 of these ratios. We've been given cosine of A is -7/25. Well, here's cosine A, so let's put in -7/25. Might as well put in what we've been given. Sine of B is -3/5. Sine of B is -3/5. In other words, we're given half of what we need to know. We just have to find sine of A, cosine of B, in order to be able to multiply these all out. So we have to eventually find this out, but I could go one step further. I could say negative times a negative times a negative. This is all going to be negative, and I can actually do this multiplication. It's going to be waiting for me. 7 times 3 is 21. 25 times 5 is 125. So I know this part is correct. This has been given to me. As long as I've multiplied this out, I always check, make sure the signs are correct. I just need to find these 2, multiply them out, subtract this from that. I'm going to be done. So the trick is, how do we find the sine of A? Well, what do I know about the sine of A? I know that the sine of A squared, not A squared, the sine squared A plus cosine squared A equals 1. That's one of my primary Pythagorean identities, so I know that's absolutely true. And what do I know? I know what the cosine of A is. Cosine of A was given to me. It's -7/25. So far, all we're doing is plugging in things that we've been given. This really doesn't have to be that difficult. So let's write this over here. you know, I can subtract cosine squared from both sides, right? If I kept this logic here, I could say that sine squared equals 1 minus cosine squared. But cosine is negative 7 over 25. So I can replace cosine with negative 7 over 25, and this is cosine squared. So here's cosine squared. Sine squared is 1 minus cosine squared. Wow. Let's square this. What am I going to get? Negative times a negative is a positive. 7 squared is 49. 25 squared is 625, I do believe. I've memorized that, but you can check that with your calculator. This is 1 minus this, but 1 has to be disguised as 625 over 625 so that they have a common denominator, so I can subtract these. And when I subtract one from the other, I'm going to get 625 minus 49. Well, 625 minus 49 is 576. Again, I make stupid mistakes, so always check this by doing it yourselves. Wow, that's sine squared. That's not sine. What do I need to do? I need to take the square root of both sides. When I take the square root of the left side, I get sine of angle A. And when I take the square root of the right side, well, the square root of, well, we already know what the square root of 625 is. It's 25. And the square root of 576 is 24. Now, be careful. Remember, up here, we determined that angle A was in quadrant 3. They gave us that angle A was in between pi and 3 pi over 2. That's clearly quadrant 3. Well, sine in quadrant 3, sine is y. Sine is negative in quadrant 3. So we have to remember to change the sign here. Remember when we take the square root of both sides, we get a plus or minus? Well, it's just the minus in this case. The plus doesn't count because sine is negative in quadrant 3. Put a little notation here, right? A is in quadrant 3. So we know what the sine of A is. It's negative 24 over 25. Sine of A is right here, negative 24 over 25. Negative 24 over 25. See, I'm just filling in. Now I need to find what cosine of B is. So, hey, I can use the same identity. I can say that sine square root of B plus cosine square root of B is 1. I can, what do I want to solve for? I want to solve for cosine squared, so I need to subtract sine squared from both sides. Cosine squared equals 1 minus sine squared. Sine square root of B. So sine B, negative 3 over 5, that's right. So here's negative 3 over 5 squared. This then becomes negative 3 times negative 3 is 9. 5 squared is 25. 1 minus 9 over 25. 1's going to come disguised as 25 over 25. And I need to subtract. 9 from 25 is 16 25ths. This is what cosine squared of angle B is. Well, again, I have to take the square root of both sides, just like I did for solving for sine. And that means I'll do it over here, cosine of B is the square root of 16 over 25. Square root of 16 is 4. Square root of 25 is 5. But what quadrant is angle B in? Up here, it said angle B is in between 3 pi over 2 and 2 pi. B's in quadrant 4. Quadrant 4, this is positive. So we have a positive 4 over 5 for the cosine of B. Wow. And I've already multiplied out this part, so I can multiply it. Gosh, I've already got this here. I don't have to have these parentheses here. I've already got them above it. Put in too many sets of parentheses. Oh no! Hence the eraser. Oh no, Mr. Hand! Ask your parents about Saturday Night Live and Mr. Bill and Mr. Hand. They'll tell you all about it. Okay, I guess you can Google it. Wow. Mr. Decker's a boomer. All right, so here we go. So what are we going to get here? We have negative 24 times a positive 4. This thing's going to be negative no matter what, right? I'm going to have a negative, and 24 times 4, I've done the math here off to the side, is negative 96. 25 times 5, 125. By the way, quick hint. You know you're doing this correctly. Well, something else might be wrong, but you know you're on the right track when this denominator of 125 is the same as this denominator, 125. If you get to this point and you have different denominators here, you've done something wrong. There's no way you're going to get different denominators in these two parts using this formula. So kind of a nice little gut check there. These denominators have to be the same. I'm subtracting 21 from negative 96. The answer is going to be over 125. That's our common denominator. And it's going to be a negative 117. So the sign A minus B is negative 117 over 125.